Hi, I'm class 1 topics of primary 6. Right now here, we're still going on with our ordinary differential equations. But ordinary differential equations, we have newly learned the operators method. Now for that part, operators method, we have said about the different ways of using it, which is something similar to the integrating factor. But right now here, we're going to try out what the particular solution for our operators method will be the same as the method that we have learned before, which is coefficient comparison or the comparison of coefficients. So we're going to achieve those by having an example. So the example in this lesson will be the second derivative of y. You add first derivative of y, then subtract 2y, like this. Then it will be equal to, so in this part, it will equals e to the power of x, then sine x. Okay, so we can have one of these types of examples. So we're going for the first method. Method 1. So for method 1, we'll need to let, as it is our coefficients comparisons, the particular solution for this particular solution to be equals, now you can have this original part, as it might just differentiate, then others cancel out. Well, it just remains this part. Or you can get it from others. Like for example, cosine, because sine differentiate, you can cosine, then cosine differentiate, negative sine. So you can have this part. Then you need to find for the first derivative. For this part, first derivative, what could this be? First part you differentiate, but wait, what if we just factorize in e to the power of x first? Okay, it can be like this. Then after that, product rule. So in front of this part, you'll get a cosine x, then you minus b sine x. But behind that part, be something similar to it. So we could change this a little bit. So we're going to use square brackets first, then sine, we can put them together. Now sine, you have this a, then after that you differentiate, you can get a negative b. So it's a minus b. So that will be for sine. Okay? Then after that, for our cosine. So cosine you can get from 1a, you can get from 1b. So that is a plus b. Then you get cosine x. Then it will be like this. Okay, this first derivative. Then x, second derivative. So we're going to use a similar method as well we have used just now. Firstly, we will have the same part. Then we have the differentiated part. So let's just say, for example, sine again. Sine a minus b, negative a minus b. So get a negative 2b. Okay? Then after that is for cosine. So for this part of cosine, here you differentiate a minus b. Then here will be a plus b. After that you add 2a. This part is what you get. Then after that you just slap all of them back inside into the original ordinary differential equations. So I think I need to write this part below. And this is equal to e to the power of x sine x. Okay, so we can find for all of the signs, I'll put them together first. And of course, this is e to the power of x. That is all the cosines. Okay, firstly for all the signs. Here, there is a negative 2b. Then you get a minus b. Then after that, you have a negative 2a. So that means you'll get negative a. Then after that, minus 3b. So it is this part. Okay, that is for cosine. Now we can add this part. So cosine 2a, a plus b, and negative 2b. So you get 3a, then minus b. Then this part is equal to e to the power of x sine x. Then we write them into simultaneous equations. So in this part, you get a negative a, then minus 3b. And this part, it is equal to 1. Then for the one below, it is 3a minus b. This is 0. So you can call this equation 1. And here is equation 2. So for equation 2, well, it is actually 3a, it is equal to b, or b is this 3a. That's why we could sub it into equation number 1. We sub it into equation number 1. Okay? So that means that that part we'll have here minus 9a. So minus 10a, and this is equal to 1. Then a would be a negative 1 over 10. So then b at this part. Wait a second. And this part, it will be a negative 3 over 10. So then after that, when you have these, you put it inside here, then you get the particular solution for y. Okay, so this is what you get. Then next, we're going to have our second method, which is our operators method. So for our operators method, at this part, so we can have d square y, then you add dy, then you subtract 2y. And this part, it is equal to e to the power of x, then sine x, okay? That we could sort of factorize the y. Like this. After that, you just find for y. Like you just divide this whole thing to the other side. Okay, so this is what you'll get. Then after that, for here, you can like just partial fractions, or you just factorize this denominator first. Factorize, well, you can be done in this step if you want, so I'm going to show you the factorized form. So it'll be like this. Then after the difference, it is 3, so you have 1 over 3. Then after this part, you will have e to the power of x sine x. So the denominator, when it is smaller, you get a greater fraction. So that means you need a smaller denominator in front, and you minus e to the power of x sine x, then over d plus 2. So this is what you get. Okay, for this part, it is what you get for now. So what else? So we're going to have the integrating factor right now. So at this part, it is e to the power of x. While inside, it will be e to the power of negative x. But for e to the power of negative x, you can solve this, and it will be sine x. Then here is dx. Then for the next part, 1 over 3, so this part it is e to the power of negative 2x. Then after inside, at first it is already e to the power of 2x. Then you have one more, so you get e to the power of 3x. Like this. So at this part, this front part, well, it's simple. This front part is pretty simple, right? So you'll directly get, so sine, that means it will be a negative cosine. But for the part behind, you will be needing to use the integrating factor. Okay, so we're going to use the integrating factor for this part. I'm going to work it out here. Okay, so this is what you have. So e to the power of 3x, then sine x. So what if we put this sine x inside this dx? That would be pretty much more simpler. Like this, that's that integrating factor. Okay, but beware, there's still one more part behind you need to. Well, this negative, so it is add. Now this part is add, so you get cosine x. But beware, this e to the power of 3x at first is behind, you differentiate, you take it in front. So you get 3, then here's e to the power of 3x. Down here, it is dx. But right now here, we don't need that arbitrary constant as, well, you can just watch the previous videos and find out why. So at this part, first part, it is still the same. Second part, this second part, add something. So for this part behind, you're going to use integrating factor one more time. So at the same time, because cosine, then it won't have any effect as it's just changing into a sine. So this part, integrating factors. So you get minus. After you take the e to the power of 3x out again, so you get 9. After here it is e to the power of 3x, then sine x dx. So for the next part over here, you can take it as algebraic equations, like those simple kind, whereas you like this part, like just one thing. Then you realize here's another of the same thing, so take it to the other side. So minus 9 becomes plus 9. So 1 plus 9 is just 10. So just divide 10 on both sides. So this is what it will be. So then we can just put it inside here. Then you get add 1 over 30 e to the power of, now beware, e to the power of 3x. Here's e to the power of negative 2x. So this is x. So then that part, this is cosine. Then after that, it is add becomes minus. So minus 3. Now this is 1 over 10 e to the power of x sine x. Okay, then after that, it's just a simple operation between these parts, which of course here you'll get a negative. So at this part, it will be 9 over 30, which is a 3 over 10. Like this. And this, when you make a comparison with that, well, you can add this particular over here. Okay? So when you make this comparison, you realize they are the same. But for past lessons, some of them, this part may seem simpler and this part may seem more complicated. But in this example, it just makes this operator's method seem simpler, while this method seems more complicated. But all of these, so in different cases, you have to try them like interchangeably. You can use these two methods. Sometimes only can use here, sometimes only can use here, or sometimes none of them or both of them. It depends on the type and this part behind. So for this part right now, I hope all of you can understand so far. So if you like our videos, don't forget to subscribe to our channel and click that like button. Thank you for your watching.